Bismillahirrahmanirrahim. Dear Honorable Moderators and Fellow, have a blessed great day. My name is Rosila Rebo. It is my great pleasure to present my study entitled Prediction Model of In-Hospital Mortality Post-Percutaneous Coronary Intervention (PCI) using Machine Learning Technique. Coronary heart disease or CHD. Artery coronary is a main blood vessel of the heart. Main function is to supply oxygen-rich blood to the heart muscle. There are two types, main left artery coronary and right coronary artery, at least one lesion or more in one patient to be treated. CHD happens when plaque formation or atherosclerosis in artery resulting in poor blood flow. The symptoms such as chest pain, dizziness, shortness of breath, numbness, and others. The impact are risk of heart attack, arrhythmia, heart failure, and others. Malaysia accounts of 13.2% from total 15.8% world deaths. In 2018, CHD became the leading cause of deaths with more than 34,000 deaths. CHD is also known as coronary artery disease and ischemic heart disease. Percutaneous coronary intervention (PCI) has been introduced by Grunzek for about last 4 decades. Main function to treat CHD, to remove blockage, dilate and open clogged or narrow arteries, thus promote smooth blood circulation. To see the point or location of the blocked artery, an angiogram or X-ray is performed. The catheter is inserted through the groin or arm, then a contrast dye is inserted to visually detect the location of the blockage. You can see here an intermittent X-ray indicates blockage artery. Then a stent balloon is inserted through a fine wire and expanded to widen the clogged artery. Perfect blood flow after PCI is performed. PCI has the same procedural complication as other surgeries such as blood clots, infection, heart attack, arrhythmia, death, and others. Problem statement. The development of the best prediction model of in-hospital mortality after PCI has not yet been developed and adopted in IGN. The advantage of PCI promise low procedural complication, but major complication of death after PCI procedure still occur. The low percentage of mortality complication impacts imbalanced data and disrupt the predictive modeling process. Our objectives are to evaluate and compare the model performance of predictive models, to determine the predictors of post-PCI mortality through information gain ranking filtration technique or feature selection, and to evaluate the model performance of imbalanced data set versus smooth data set. This literature review met my study requirement. The similarities are low mortality rate, same general objective of finding a predictor of deaths, the algorithm such as gradient boosted ANN, information gain ranking for feature selection, and AUC recall F1 score sensitivity, specificity, and accuracy for performance evaluation. Besides of previous LR, additional methods used are metric correlation to reduce attributes, smooth sampling method introduced by Chawla to balance imbalanced dataset, algorithm KNN, and additional performance evaluations such as classification error, mean square error MSE, time measurement, false positive rate, and false negative rate. For methodology, there are 3 main phases involved. First, data management, second, data pre-processing, and third, machine learning. Platform and software used are Microsoft Excel, SPSS, and RapidMiner. IGN accounts 30% of NCVD for 10 years and involve more 20,000 patients with 40,000 lesions treated. The reality of acquisition data consists of incomplete data, missing data, error, inconsistent, and outliers. For pre-processing phase, elimination of meaningless features, not available and not known data were categorized as missing data, attribute elimination, data with more or equal 50% missing data, extraction of useful mining lesion data in section 7, data integration between main data to procedure data section 7, eliminate outliers and treat as missing value, eliminate same meaning features, and for data transformation, we have generate new features, replace missing value, and one-hot encoding. All categorization processes and range values are guided by the NCVD PCI annual reports. The dataset was divided into three sets: demographic sets, intra-procedure sets, and post-procedure sets. Three trace classifications, model prediction has a strength predictive evaluation at three different stages, hence provide effective medium of clinical decision-making support. Feature selection. Feature selection using information ranking gain technique IG, one of the filtration method, selecting IG weight above 0. Then metric correlation is performed and only selected a correlation weight above 0.5. This method reduces the number of attributes and ready for the modeling phase. Smooth. Increasing the minority that sample using the Euclidean K&N algorithm approach at neighborhood k equal to 5. Finally, a 1-to-1 ratio dataset is perfect. Model development. Data is divided into 70% training and 30% testing. 70% training using a 10 cross validation as estimator. 30% of the test is applied on 70% training data. Algorithm. Gradient boosted a powerful decision-making example. K&N concept of the nearest neighborhood, and ANN stimulates the way the human brain processes information. For modeling, imbalanced data versus smooth were experimented at default setting only. For model comparison, data smooth have additional parameter tuning. Result descriptive analysis. Graph showing PCI trend for 10 years. The numbers of procedures is increased every year in line with the increase of CHD patient. Also shows a low mortality rate. Statistic for PCI. The annual PCI average is about 2,841 procedures. Age mean was 58.2 years old. Prominent in male and Malay race with concomitant disease, dyslipidemia, hypertension, and diabetes. For post-PCI mortality, mortality rate is about 1%. Mean age was 62.95 years old. Significant distribution in male and Malay race, also concomitant disease with dyslipidemia and diabetes. Result for feature selection. The main feature of the demographic dataset A, B, and C are systolic group, IABP, and complication respectively. The features reduction percentage is more than 60% for all datasets. Result for imbalance versus smooth dataset. Positive class was labeled as dead. Sensitivity represents predicting deaths. Specificity represents a prediction of survival. Result shows for set data A, B, and C in the next page. For overall, for imbalanced dataset, high performance on accuracy and survival prediction, low performance on mortality prediction, AUC score and F score, good performance for false positive rate, but insteadly for false negative rate. For balanced dataset, smooth, high performance on overall assessment. Classification error increased as accuracy decreased. MSE also increased but is still close to 0. Model comparison for smooth dataset. For dataset demographic, the best parameter tuning was performed by gradient boosted with learning rate of 0.1. For dataset intra-procedure, the best parameter tuning was also performed in gradient boosted with learning rate of 0.1. For dataset post-procedure, the best parameter tuning was also performed in gradient boosted with learning rate of 0.1. The best model score. Score 1 for the best performance score. The lowest total score shows the best performance. Gradient boosted provide the best performance for the entire dataset. My finding objective. Prediction models gradient boosted gave the best performance at learning rate of 0.1. Complications, cardiogenic shock and AIBV usage are three main factors that contributed to post-procedure mortality. Balanced dataset smooths be able to predict both survival and mortality excellently. Conclusion, feature selection using filtration, information gain ranking, and combination with metric correlation successfully select important features for all datasets, thus improving model performance. The application of smooth technique improve the performance of the model and be able to predict both survival and mortality classes efficiently. The gradient boosted algorithm performed well to all datasets, and best performance was seen in prediction model of dataset C. Study importance and contribution. For institution, development of 3 tiers of classification models has strength predictive evaluation at 3 different levels, as well as a medium for clinical decision-making support. For patient will be revealed with knowledge, awareness, treatment, and intensive care after the procedure or vice versa. For society, healthy life promotion to emulation, practicing a healthy lifestyle in order to maintain beautiful life, love our heart. In this opportunity, I would like a wholehearted thank you to my beloved supervisor, Dr. Afzal Adam, Dr. Aslan Hussein, Dr. Shrayahani, and PCI team NCVD CRDIGN, as well as to my beloved husband and kids. Thank you for your support and guidance.